Okay, so now we're going to be looking at the natural logarithmic function. We're going to be looking at differentiation. So have your notes printed out, and what I'm going to point out is, what I have highlighted in yellow, and it says, to take the derivative of a natural log, you're going to draw me a fraction bar, put whatever's behind the ln on the bottom, and then put the derivative of the bottom on the top. So we'll go through a couple of those a couple of those problems. All right, so here we go. Find the derivative. F of x equals natural log of x squared plus 3. All right, so whenever you've got this natural log and you want to take the derivative, all right, move that out of the way. Here we go. You're going to draw me a fraction bar. Whatever's behind the ln on the bottom, or whatever's behind the ln goes on the bottom, and then the derivative of that will go on the top. So the derivative of x squared plus 3 is just 2x. Now you want to look, that fraction has 3 terms in it, and you want to ask yourself, hey, can I reduce anything? But there's nothing that goes into 2x, x squared, and a 3 besides a 1. So there we go. Easy, easy. All right, let's do the rest of these. All right, so f of x equals 4 times the natural log of x squared. So this one's different because it has this number 4 in the front. So let's see how we deal with that. All right. So the derivative, if you have that number in front, you're just going to keep it as 4 times it. And it's easier to just go ahead and write it as a fraction since you know you're going to have a fraction too. So just keep it as 4 over 1 times. All right, draw me a fraction bar. Whatever's behind the ln goes on the bottom, and the derivative of that goes on the top. So the derivative of x squared is 2x. So if I were to multiply straight across the top, I get 8x, and on the bottom I get x squared. And you can reduce this. They both share an x in common, so you can knock out one of those x's. So my derivative is 8 over x. All right, let's keep going. I am missing C, aren't I? Okay, let me see. Let me go back and figure out which one I'm missing. All right, so evidently I'm missing this one in here. Right, f of x, so I'll just write it in right here. F of x equals 3x times the natural log of x to the 4th. Now I wanted to point out the big difference in C and in B. In B, you just had a 4 in the front. Okay, so no big deal. You just multiply 4 by your answer, by your derivative. All right, but now this one is different because I have a 3 and an x in there, so I'm going to have to do a product rule. So think about product rule from VCal 1. Anytime you got an x times the natural log of x. You got those 2 functions. So you got to do a 1d2 plus 2d1. So we're going to call 1 3x. We're going to call 2 natural log of x to the 4th. All right, so let's get d1, the derivative of 1, and d2. All right, so the derivative of 3x is just 3. Right, so take this derivative, whatever's behind the ln on the bottom, derivative of that on the top, so the derivative of x to the 4th would be 4x cubed, all right? And then you can simplify that because 3 of the x's will cancel out. So my derivative of the second is just 4 over x. All right, so remember product rule. Product rule is 1d2 plus 2d1. We can't forget any of that stuff we learned in regular Cal 1. I might have said VCal 1 a minute ago. I teach that class too. But remember from regular Calculus 1, our product rule. All right, so let's fill that in. We have 3x times 4 over x plus natural log x to the 4th times d1, which is 3. All right, so when I'm simplifying this, right, see what happens here are these x's are going to cancel, and I'm just left with 3 times 4, which is 12. Plus, you are not allowed to multiply in this 3 and that x to the 4th. Whatever's behind the ln is locked in behind that ln. You can't mix anything in it, so you're just going to write this. Now, truthfully, on your homework, I'm fine with that answer, but if you have one like this on your quiz or your midterm, you won't see an answer like that. Factor out what they have in common. They both share 3, so we can do 4 plus the natural log of x to the 4th. Like that. That's more than likely that's the answer you would see on the quiz, those multiple choice quizzes, but truthfully, if you have a homework problem like this, I'm okay with that. 12 plus 3 times the natural log of x to the 4th. All right, now we'll go to that D. All right, f of x equals natural log of sine of x cubed. So let's think about our trig. All right, so to get the derivative, we draw a fraction bar, right? Whatever's behind the ln on the bottom, and then the derivative of that on the top. So the derivative of sine is cosine of that same angle times the derivative of the angle. So times the derivative of x cubed, which would be 3x squared. All right, so let's write this a little cleaner. All right, I can't do anything with that 3x squared, but we know from trig, all right, cosine over sine is cotangent. Okay, so that's probably the answer that you would see in the back of the book or the quiz on that one. All right, and then E. Now, I'm going to do this one really, really fast, and this is not how you want to do it, so don't try to copy this down while I'm doing it. You want to make these simple when you can, and here's one that you can simplify greatly. All right, if we did it, all right, if we didn't use those properties from algebra, you know the first thing I'm going to do is rewrite that square root as a half power. All right, now I'm going to fly through this really fast. Do not copy it down. This is not how you want to work it. All right, but to get the derivative, you do whatever's behind the ln on the bottom, and then the derivative of that on the top. Well, the derivative of that, you're going to have to use a chain rule. So it'd be 1/2 times the same parenthesis, but drop it by 1, which gives me a negative 1/2. Power times the derivative of the inside, which is 4x cubed minus 4, and then you got to put all that together, and sometimes people aren't so good with that. You don't want to do it that way. You can, and it's fine, and it gets you the right answer. It's just that's the harder way to go. So you want to remember, and I put them in your notes, those properties from algebra. What you want to do whenever you have this, okay, you want to rewrite first. Make it easy on yourself. All right, so we learned in algebra that when you do have that exponent, you can rewrite it in the front of its own log. So I can drop that half power, and now this became a whole lot easier for me to take the derivative. This works like the example B did now. I'm just going to keep that 1/2 times, all right, draw your fraction bar, whatever's behind the ln on the bottom, and then the derivative of the bottom on the top. So that's 4x cubed minus 4. All right, and so if I multiply straight across the top, I get 4x cubed minus 4. Now you can go ahead and distribute the 2 if you want to. I'm going to leave it out because it won't matter. It gets you the same answer either way, but I know that in the top, if I also factored out a 2, but I can reduce that 2 in there, and so I get everybody knocks out by 2, so I get 2x cubed minus 2 over x to the 4th minus 4x as my derivative. So when you can use those properties of algebra, you definitely want to use it. So that was that power rule property. And then let's do another one using some properties from algebra. Oh, there's C. Okay, so already worked it. I don't know what happened and why it got posted like that, but already worked it. So we'll go on to the next one. Sorry about that. All right, we're doing the natural, y equals the natural log of x plus 2 times 3x minus 5. You would, again, like draw me a fraction bar, put the x plus 2, 3x minus 5 on the bottom, and the derivative of that on top, but that would be a product rule, and we want to make it a little bit easier. So we can rewrite this, and when I have the natural log of a product, I can rewrite it, and I can add those two. All right, so when you're doing a product, you can split apart the logs with the plus. Okay. All right, because we know logs are fancy exponents, and when I am multiplying the same base, I add up those exponents. And now I can take the derivative, so draw me a fraction bar, whatever's behind the ln on the bottom, derivative of the bottom on the top, same thing here, whatever's behind the ln on the bottom, derivative of the bottom on the top. Now, you're not, if your problem starts in one term, you're going to need to end it in one term. So this answer is not okay. I need to put those fractions together. That is simple algebra, but a lot of times people have forgotten it. So when I'm teaching my beginning algebra classes and we're doing fractions and we have something like this, we use a method called love your fractions to put them together. And it's called love your fractions because you make a heart, but you multiply this way and first, and then you do this way, second, make that heart, take the sign of the middle, and then to get the bottom, you just multiply the bottoms, and it was a really fast way to add and subtract fractions. So we're going to use that concept here. So if I multiply this way, 3x minus 5 times 1, I just get 3x minus 5. And if I multiply this way, distribute that 3, I get, and I take the sign in the middle, I get 3x plus 6. And then you're just going to multiply the bottoms. Now, the good news is that you do not have to multiply that denominator out. You can leave it like that, but put together the top, and you would have, what, 6x plus 1 over x plus 2, 3x minus 5. Really, really, really fast way to put your fractions together called Love Your Fractions, and we'll use it again in just a minute. And then the last one of these, y equals the natural log of 5x. All right, so again, to get the derivative, you draw me a fraction bar, whatever's behind the ln. And when I say that, I mean whatever's behind this first front ln. So that goes on the bottom, which would be natural log of 5x. And then the derivative of the bottom goes on the top. So when I take the derivative of the bottom, I say, all right, we'll have a natural log, so whatever's behind the ln goes on the bottom, and the derivative of the bottom goes on the top. All right, so let's do this algebra simplification. These 5s are going to cancel. Now be careful that you don't write me just an x on the top. It is a 1 over x. And then the natural log of 5x on the bottom. All right, so I'll skip this step in the future, but if you think about it, you've got 1 over x divided by natural log 5x. That's 1 over x times the reciprocal of that. So you just get 1 over x times natural log 5x. Be very, very, very careful that you don't try to multiply that x and that 5x. Remember, whatever's behind the ln is locked in behind the ln at that 5x. Okay, but that x just drops to the bottom. Okay. That 1 over x, you can rewrite it. All right, and then we have 2 more examples in this section. One is looking at logarithmic differentiation. So I gave you your steps in your notes, and you'll make sure you have them handy, because we'll go through those steps as we do this one example. There is one like this in the homework. All right, so let's do it. All right, use logarithmic differentiation to find y prime. All right. First thing I'm going to do is follow my step 1. It says take the natural log of both sides. So natural log of y equals the natural log of this thing, x minus 2 squared. And I'm going to go ahead and write it as x squared plus 1 to the 1/2. Okay? All right, now step 2 is to use properties to rewrite it and expand. And what that means is you're going to fool with the right side, okay? Use those properties from algebra. All right, so I am going to need that quotient rule for the logs. All right. And so when I've got a quotient, I can rewrite it as log minus log. So x minus 2, all right, squared. And then instead of having that squared power up there, you know, any exponents, where do they go? They drop down in front of their own log, minus the natural log of the bottom. And I'm going to do that same thing. I'm not going to leave that power up there. You know, it drops down in the front. Okay. So that's what that step 2 means. Use the properties to rewrite it and expand it. All right. Step 3 says take the derivative of both sides. And I should have written take the derivative of both sides implicitly. Okay. And we're going to do an implicit differentiation problem next. So let's go back. You want to take the derivative of both sides implicitly. So you should be familiar with implicit differentiation from regular Cal 1, and means anytime you take a derivative of a y, you follow it with dy dx or y prime. It's looking at the way I wrote my steps, we went with y prime. So anytime you take a derivative of a y, you follow it with y prime. Okay, so natural log of y, the derivative of that would be, you look at it, draw me a fraction bar. Whatever's behind the ln goes on the bottom, and then the derivative of the bottom goes on top. And anytime you take a derivative of y, you follow it with y prime. All right, and let's take the derivative of this. I'm going to do 2 over 1 times. All right, whatever's behind the ln here, derivative of the bottom on top, and then the 1/2. Whatever behind the ln on the bottom, and the derivative of the bottom on the top. So let's put that together and clean it up. So if I multiply, I get 2 over x minus 2 right here. Right. If I look at it and I cancel out, these 2's are going to cancel, and I get a minus x over x squared plus 1. All right, so that love your fractions that we did just a second ago, we're going to do it this way. All right, so you're going to multiply that way. So I'm going to take that 2. Oh, hold on. All right, 1 over y prime. All right, I'm going to take that 2 and distribute through there. I get 2x squared plus 2. All right, and when I multiply this way, I'm taking the sign of the middle, so I've got a minus, and I'm going to distribute that x through there. So distribute a negative x through there, you get a negative x squared and a positive 2x over multiply the bottoms. Okay. All right, so I'm going to carry this right up here. So I get 1 over y prime. All right, if you put the top together, I'm getting 1x squared plus 2x plus 2 over multiply the bottoms. Okay. All right. That's step 4. Simplify that right side. Put it together. All right. Now, step 5 says we want to solve for. I want to solve for y prime, so I got to get rid of that 1 over y. So what I'm doing to solve for y prime is I'm multiplying both sides by y, because that'll cancel that out. Right, but now you don't want to write on this right side times y. Okay, you want to multiply it by what y is. Y is just your original problem, which is x minus 2 squared over, I'm going to go ahead and write it with that 1/2 power. All right, so now y prime would equal, let's see what happens. So if I do this, all right, you've got an x minus 2 squared on the top, and you got one of them on the bottom. So one of those is going to cancel and leave that to the first power. And then you can combine these two because they're the same. Remember, that's got an exponent of a 1, and that's got a 1/2. So when you add those together, all right, you've got 1 plus 1/2, you've got 3/2. Okay, remember, 1 plus a half, you're just looking at it like this. And if you want to love your fractions, you got 2 plus 1 over 2, 3/2. Okay. And then on the top, you can just leave these as a product. You don't have to multiply that out. You can just leave it like this. Okay. You have a logarithmic differentiation problem to do. Make sure that you try that in your homework. Okay. And then because you have to take the derivative implicitly, I gave you an extra example, just implicit differentiation. There are a couple of these to practice in the homework too. Let's do this one. All right, so remember, implicit differentiation means every time I take a derivative of y, I follow it with y prime or dy dx. I'll do y primes here. Okay, so whenever there's an x and y in the same term, I have to do a product rule, that 1d2. So first I'm going to call for x, and 2 is going to be y. So 1d2, our derivative of y is just 1, follow it with y prime, plus the second one is y times the derivative of the first, which would be 4. Okay. All right, and now I do this derivative of this natural log, so whatever's behind the ln on the bottom, and then the derivative of the bottom on the top. Well, again, that's another product rule because I'm going to call 1 x squared and 2 y. So that would be first times the derivative of the second. The derivative of y is 1, follow it with y prime, plus second times the derivative of the first. And then if you keep on going across the equal mark, derivative of 7 is 0. All right, so let's write this a little bit better. So that's 4xy prime plus 4y. All right, now what I'm going to do is I'm going to split this fraction up. Okay, I'm going to stick that x squared y under both of those numerators. So what I'm going to do is do this, x squared y prime over x squared y, but I don't want to write that. I want to go ahead and simplify what happens to the x squares, so they're going to cancel. So I'm just left with y prime over y. And so I'm going to write it as 1 over y prime. Okay, and then if I do the second one, I'm going to do 2xy over x squared y. So think about what cancels here. One of the x's and both the y's would cancel. So I'm just left with 2 over x equals 0. All right, so implicit differentiation, you had to take the derivative of every single term. So we did here, here, and here. Right, and now you want all of your y primes on the same side. So that's 4xy prime plus 1 over y prime. And anybody who's not a y prime goes to the other. So that's going to be a negative 4y and a minus 2 over x. Factor out a y prime. 4x plus 1 over y. And then to get the y prime by itself, which is the whole goal, you divide by that parenthesis. All right, now this is an improper fraction, and we don't want that. So, not an improper fraction, sorry. It's but it's got these. It's a complex fraction, so we want to get rid of that. So the little bitty denominators that have are x and y. So I'm going to multiply everybody by an x and a y to get rid of the complex fraction. All right, so when I do that, all right, let's see what I get. I get a negative 4xy squared minus, all right here, the x's cancel, and I just get minus 2y. All right, on the bottom, I get 4x squared y plus, all right, and the y's cancel, I get plus 1x. Okay, and so there is my derivative. A couple of days to practice in the homework. Make sure you remember that implicit differentiation from regular calculus. Fun. All right, good luck.